Hi, I'm Kai and today I'm at Siemens on the SPS fair in Nuremberg. Today I want to talk about a new device in terms of switching and protection of motors. And therefore I invited Eric. Thanks Eric for having you here on my channel. Can you maybe introduce yourself?
Yeah, my name is Eric Fröhlich and I'm the product owner for the new SIMATIC ET 200SP e-starter, which is the new product we're presenting today.
E-starter means it's an electronic starter, right?
That's correct.
That's not really something new. Can you explain us what is special on your product?
Yeah, well, what we have here, it's a fully electronic starter, which we are calling e-starter. So it's integrated into the SIMATIC ET 200SP system. That's why the full name is SIMATIC ET 200SP e-starter.
That means it's an extension on the ET 200SP, right?
That's correct. So it's fully integrated here, as you see here, in the ET 200SP system. So you, by means of this base unit, you can simply dock it next to the next I/O device from the ET 200SP system, and therefore we say it's completely integrated also in our TIA portal.
Yeah, that means you have all the data directly available in TIA portal. Which range do you can deliver from this device?
So the data we're providing for full transparency, so we have current, voltage, power values, as well the complete diagnostics of my application and as well and status of my motor. And that is also, everything is transmitted cyclically. So we were the process image to the PLC, so every single measured value and diagnostics data are immediately available at the PLC.
Yeah. Let's talk a little bit more about the hardware topic. In which range of current or power for motors you can deliver this?
So we have two current ranges actually. So the first one going from 0.1 to 2 amperes, and the second one is from 0.7 to up to 7 amperes. So that's run about 3.5 kilowatts, depending on which motor you have.
What is a typical application for this?
So the most common application are motor loads. Typical uses are, for example, in the conveyor technology, but also pumps pumps and small fans are also a typical application. But we are not only addressing motor loads, we're also addressing resistive loads and capacitive loads as well.
Yeah, that's a wider range of applications.
That's correct.
Yeah, maybe we can have a look about the function, because as far as I know, it's based on semiconductor technology. Is there something special about this technology?
Yeah, so we are, as we said at the beginning, it's fully electronic. This means this electromechanical component is not anymore here for switching off the load in case of a short circuit. And that's exactly the biggest advantage of this technology. In case of a short circuit, we can shut it down about 1,000 times faster compared to a normal fuse or circuit breaker that we have today. So we're working in microsecond range. So the short circuit disconnection occurs in about 4 microseconds.
This is really fast.
Yeah, and the biggest advantage is, so you have to imagine, with this speed, we are avoiding that the short circuit current goes up in the kiloamp range. Yeah. So we are about 150, 160 amps, and that's it. So we don't have any destructive short circuit current anymore.
Yeah, but anyhow, it just trips when the short circuit happens. That means, what is the big advantage of this fast tripping?
Well, imagine if you're in an application and a short circuit happens. So, of course, you need to detect and find out what was the cause of the short circuit, repair it, and then hopefully you have some replacement parts. For example, a replacement fuse, or maybe the circuit breaker got damaged because the short circuit current was too high. Then you need also to replace the short circuit, and that time is still the application is not working. So that means this whole downtime time, you have to resolve it as fast as possible. With the e-starter, you would just need to press reset and then restart again. Then you can restart again. So there's no need to replace any device in my application, because the e-starter took care of the destructive short circuit current. So nothing would have gotten damaged in this application.
Yeah, because this e-starter gets less force than on a normal short current on a normal MCCB because of the fast tripping. You talk about the reset possibilities.
Yes.
Maybe we can make a short simulation here.
Yeah, sure.
So we can see the motor is running as I understand, green means always okay at Siemens, right?
That's correct. So here in the lower part we see the display of the direction of rotation of the motor. So we see now the motor is turning right.
Ah yeah, I see you have counterclockwise and clockwise.
And clockwise, exactly. And now the motor is running and let's say a short circuit happens. So what we can do here is it's not just a simulation. What we do with this handle here is we're short circuiting the phase 1 and phase 2.
Ah, they're really hard.
So it's a really hard short circuit, which I will do right now.
Yeah, normally you would expect some flash or something.
You
like
would see the lights here
yeah,
flickering or somebody running out and say, hey, what have you done? My fuse got blown out in the back. So you see here the diagnostic. So you see here in the LED, the short circuit LED is lighting up and it's telling you here on the load side, this is the load side LED, that there is the short circuit happening. So what you usually do in the facilities, you go there, you correct the cause of the short circuit, then take out the starting command because you don't want the motor to automatically start again. You do a reset either remotely or on the device. And now the application is ready to start again. So that's it.
And because of the integration to the TIA portal, it's also possible to reset from an HMI, right?
Exactly.
You have here also a small add-on, let's say, on the lower part here with some DIs. This can also be used to integrate, for example, a reset button.
Exactly. So this is a module for local control. If you, for example, during commissioning want to test the application before the PLC is even running, then you can plug this into the e-starter and wire to this to these terminals here, starting commands, for example, start the motor right, start the motor left, or stop. And then you can test if everything has been wired correctly. So this is an optional accessory which facilitates the commissioning procedure.
Yeah, now let's talk about another story in the lifetime of a machine is maintenance.
Yeah.
As you told us, it's an electronic motor starter, but anyhow, when you want to change, for example, the motor, you need to make sure that the motor starter is disconnected from the motor on a mechanical way, not just electronic.
Yes. So we have a galvanic isolation here because we're switching all three phases. But interesting would be, of course, if you are planning to do a maintenance work in the motor or in the lines to that. So of course, you need to shut down the application, and you have a possibility here to turn this handle counterclockwise. You have two alternatives. Either you bring it here to the park position, and you can bring this knob down. So you have here a lock where you can
lock out and take out, right?
Exactly. Okay. Or so there, if you put a padlock here, then it cannot be turned on again. And here you have a mechanical disconnection as well. So that is very important to make sure that there is no voltage on the motor side. And the other alternative would be, of course, to take the complete device out, and then
nobody can
switch on.
Ah, yeah, quite solution, quite nice.
And simply turn it back again, and the device is ready to go again.
Yeah. Let's talk about another topic. Nowadays we have high efficiency motors, and this could be sometimes a problem for a normal MCCB, right?
Yes.
Because of the big inrush current.
That's correct.
With a full electronic starter, you have some solution for this?
Yeah, that's correct. With the e-starters we have brought, we want to also address this challenge. We know many customers are forced to upgrade to high efficiency motors, and these high efficiency motors bring up the challenge of inrush currents and high starting currents. And directly proportional to the current, we have also the torque. So the challenge is these inrush currents could lead to trips of the protective device that are upwards. So what we do with the smart start function is that we neutralize completely the inrush currents. So these are no topics for us because we have a phase optimized switching of the MOSFETs inside the e-starter. And second, what we do also with the smart start function is we reduce the starting current of the application to up to 30 to 40%. So instead of having, for example, 100 ampere starting current, we would have only 30 or 40 amps. And this enables, for example, here I can demonstrate this. The motor is turning right now. If I would the e-starter is always a reversing starter, so we can make a reverse operation.
Okay.
If I do a hard switch to counterclockwise, you usually would need to put a small delay because of this current peak. Now with the e-starter, I can just turn it immediately, and the e-starter takes care of these current peaks, so that I don't need to implement this additional delay to make sure that no device will trip or no fuses would trip in case of a direction of rotation. This is even worse because when you make a direction of change of rotation, then you have even the counter torque to overcome. That's why this is the let's say most critical switching of high starting currents.
Yeah, thank you very much, Eric. If you have further questions about the new e-starter, please write it down in the comment. We also put you some more information in the video description. If you like the video, please drop a like. Don't forget to subscribe and activate the notification. Hope to see you in the next video from Kai and
Eric.